In this part, we will visualize the vectors. For example, the velocity vector and the streamlines. This is the objective for this part. Okay, and you can see this is skin friction coefficient distribution over the front wing, and our vector visualization will be based on this. For example, now we want to visualize vectors cutting through this plane. So in order to do this, we need to generate a plane. So we need to go to the derived. We need to go to derived parts. We need to go to derived parts. We need to go to derived parts and generate the plane. So new right click, new part, section, plane. And we've actually done this earlier. And now we want to visualize the plane in here. So the direction is correct. We just need to change the origin, for example. And that we want to move it. Okay, I don't want to move this one. And that is point -1. Let's see, where is it? Okay, so it's still in that. We want to visualize the plane here. So -1.5. Okay, so probably closer to the center part, 1.3. Okay, so this is the location. We want -1.3 and just create once, remember? Then, okay, so this we want to visualize the velocity vector in this plane. So we want to visualize the velocity vector in this plane, derived parts. Okay, and now let's go to the geometry scene. And we already have the scalar. So this is scalar over the wing, and we want to create a not scalar, but vector. Okay. So we will have a vector displayer and a part, and we want the part to be this plane. Yeah. And automatically we can see the vectors, but it's not so neat to see. Okay, because the grade is so very fine within this part. And now let's do some treatment. So the vector field, and the vectors are highlighted or contoured by color-coded by the velocity magnitude. So this is default. And we can do something here. And we can change the display mode. And we can change from the vector to line integral convolution. So this is a better way to visualize. And And let's have a better view. Parallel views. We are viewing from negative z and up y. Okay, so this is a plane. And there's something we can do. We can, because now the wing is hiding the view, we can perhaps disable the scalar. Okay, we can see the integrated, it's called, okay, we can see the, okay, for now, we can see the line integral convolution. This allows us to see the flow separation. So for example, here, under this wing, and we can see the flow separation, which is not ideal. And for the front wing, we don't want the flow separation because this will lose the downforce. It's like the airfoil. We don't want the store to happen, right? Flow separation over the airfoil. This is not good. Okay, so now we've seen the vector and basically the streamlines within a plane. So what you can do is, if you're interested, you can translate this plane or generate other planes to see the streamlines and detect flow separation. Okay, and the next step is to generate the streamlines. In order to see the streamline, and we don't want the streamline everywhere, but in a controlled way. So we want to see the streamlines from a certain location. So the first step is to generate some seeding points. So we go to derived parts, new part, probe, line. Okay, so the line will be the starting point of the streamlines. And the line is determined from by 2 points. And let's just make point 1. And let's see, -4 is, and so I need to change the perspective a little bit. Okay, -4 is fine, and y we want it to be 0, and the z is maybe -0.2, and x we want it slightly upstream, the first point, 1, and they share the same x, 1, y is 0.5, and z -0.2. Okay, so we are going to seed the particle from here. Let's move it towards this side. It will be easier to see. And let's see, z is 1 minus 1.2 minus 1.2 and a bit more, 1.4. Okay, minus 1.4, sorry. Minus 1.4 and minus 1.4. Okay, so this will be the seeding point, and there are 20 points within this line. Maybe it's too small. Let's move it to 40 and create, close. So you can see the seeding points in here. Now we want to generate the streamlines, still in the derived parts, new, and the streamline. Okay, and the region we don't need to change. And seed mode, part seed, and we want to choose seed parts, and that's the line probe we have. You can also choose surface as seeding parts, but you will get potentially much more. And we don't have V, so only one. We can get, for example, 20 streamlines. And new streamline displayer, we create, close. Okay, so for now, you can see the streamlines. And okay, so this is a streamline. And potentially we can add more streamlines. So what we can do is I just use 20. So if I do 40, and it will produce more streamlines. And you can see there's also flow diverted. Yeah, it's not within that plane, but it's diverted to the other. The seeds is going into other planes, and that's the vorticity. So in the next step, we will visualize the vorticity. Okay, now you can see it's more complicated visualization. And if we go to the other plane, we can hide the scalar. This scalar. Oh no, no, this one. Okay, so you can see how the streamlines combines with this original skin friction distribution and where how the streamline goes. Yeah, if we have a top view, that could be a, so we are viewing from positive y and up is minus x. So this is the top view, and we can see the streamlines are slightly diverted, and then there is a vortex. Yeah, so there's a vortex in the flow. If we have a front view, um, viewing from positive x and y up. So this is a positive view, and you can see the vortex. So the flow from beneath the wing is guided upward. Okay, so this is how the flow evolves, or the streamlines evolves within the from the seeding point. Okay, and you can try the seeding at different locations. And now let's do one other seeding approach. We can have horizontal seedings. This is vertical seeding. Let's and generate some horizontal seeding. And for now, I can just double. Okay, so what we need to do is need to create new streamlines, new points first of all. So we have new points and no points. We want to have probe line, okay? And we just want it to be axis from 0. So let's have a front view, viewing from positive x, y up. Okay, so we want the seeding from here, okay? From slightly below the wing. So now let's x 0.5 and 0.5 and y 0, z is 0.5. Oh, 0.5 is too far away. 0.2, yeah, and this is also 0.2. And no, so it should be negative 1.5. No, 1.7, 1.9. 9, good. And y 0, x can be minus 0.4, minus 0.4, is here the same x. Now let's move to this side. Okay, x is still, and let's make it 0.4. Now x is upstream, 0.4 is upstream, and y is the same, and that and seems not symmetrical. 2.0. Okay, this is good. And create, close, and we will have a second probe, and there are 20 points. And we can make more points. Resolution, we can make 50. So you will have more points. There are more points. And with these points, we can do the seeding. And now what we do is in the streamline, we just change the source seed line probe, by we choose this line and disable the original one. And you can see how the streamlines evolves. Maybe it's too thin. Let's see if there's a way to make it thicker. Seems it's not possible, but there's something new we can find. And let's see. And you can see the flow separation. Some of the streamlines are going backward and then forward again. So that's the typical flow separation. And if we move towards the downside, let's have a better viewing direction. From negative y and negative up is negative x. Okay, so you can see the flow. There is a rotational flow. That's the flow separation. Okay, so we can see the flow separation, which is how it looks like in 3D. Yeah. And this is also very important skill to study the flow field. Yeah. Okay, so in this part, we visualized the vectors within a plane and also the streamlines through a seeding line. These are the two important skills for post-processing and how do you interpret your data. And if you are aerodynamic engineer, you perhaps want to remove this or improve the flow separation. And through the streamlines, you can see how it is improved.